In this video, we're going to look at how to rotate a geometric figure around the origin. So there are three common rotations: 90 degrees clockwise, so that would be rotating this way. There is rotating 90 degrees counterclockwise, which would be going the opposite direction. And then there is rotating 180 degrees, so that would be rotating 90 degrees once, then 90 degrees again. Rotating 180 degrees can also be done in the opposite direction, 90 degrees and 90 degrees again, and they will give you the same result, whichever way you go for 180 degrees. So we're going to start by looking at these points on this triangle and rotating them in those three different ways. So if we rotate this triangle 90 degrees clockwise, so that means it's starting in this first quadrant, and I'm going to rotate it clockwise for a full 90 degrees. So that means now I've completely moved this axis a whole 90 degrees to line up over here. So now I want to look at where did those points end up. The points that we started with are labeled in this table, and the new points, or the prime points, we're going to list them out. So the point 2, 4, point A, was originally 2, 4, and now it is the point 4, negative 2. The point 3, 1, point B, is now the point 1, negative 3. And point C, 1, 2, is now the point 2, negative 1. So let's look at what happened to each of those points so that we can write a rule for it, just like we did when we were talking about translations and reflections. So for 90 degrees clockwise, if we look at where we started with the point 2, 4, it became the point 4, negative 2. So the x and y values switched places, and one of them became the opposite sign. Okay, so the x and y coordinates switch. And the x that we originally had changed signs. Now let's look at what happens when we complete a 90-degree clockwise rotation, and we're going to write our new rule for those coordinates. So if this is the case, that means we started with the point xy, and it became the point y, comma, negative x. Now I want to point something out to you. If we go back to where we started, a 90-degree clockwise rotation is the same thing as a 270-degree counterclockwise rotation. Okay, so I'm going to do that again. If we start here, if I rotate 90 degrees clockwise, okay, that puts me in this quadrant. Now if I rotate 3 times, that's 270 degrees, that lands us in the same place. So if I go 90 degrees, 180 degrees, 270 degrees, that's the exact same thing, but we were going in the opposite direction. So I want to note that a rotation of 90 degrees clockwise is the same as 270 counterclockwise. Now let's look at a 90-degree counterclockwise. So this time we're going to start in this quadrant, and we're just going to rotate 90 degrees to the left once. So that was a 90-degree counterclockwise rotation. Let's see where our points ended up. So point A started out at 2, 4. It ends up at point negative 4, 2. Point B started at 3, 1. It ends up at negative 1, 3. Point C was at 1, 2. It ends up at negative 2, 1. So what happened with these points? Okay, X and Y switched places again, but this time the original Y value, which was 4, became negative in the X value space. The original Y value of the original Y value of 1 became negative 1 when they switched places. The original Y value of 2 became negative 2 when they switched places. So X and Y switch. And this time, the original Y value changed signs. So we started with the point XY, and it became the point negative YX. Now let's look at if 90 degrees counterclockwise is the same as 270 in the opposite direction. So again, we're going to start here in the first quadrant. If I go 90 degrees counterclockwise, is that the same as if I rotate 270 clockwise? Let's see. So that's 90 clockwise, 180 clockwise, 270 clockwise, and we end up in the exact same place. Now we're going to look at a rotation of 180 degrees around the origin. This one is a little bit more straightforward because either direction you go, it doesn't matter. So we'll start back in our pre-image position and we'll rotate 180 degrees either way. So that's 90, that's 180. Okay, so let's see where A ended up. It started at 2, 4. It ends up at negative 2, negative 4. B was at 3, 1. Now it is at negative 3, negative 1. C was at 1, 2. Now C is at negative 1, negative 2. Okay, so this time you can see the numbers stayed the same, but they all got the opposite signs of what they started with. Now I want to just say it one more time. If you're rotating 180 degrees, it does not matter if it's clockwise or counterclockwise. Okay, I did make a little note down here for you. Clockwise, it's the direction that the hands on a clock would move. Counterclockwise is the exact opposite of that. So these are kind of our exploration. This is more of our summary of what happened. These coordinate rules, I wouldn't necessarily recommend that you memorize them, but it would help you if you kind of keep in mind the visual representation of what's happening. Now I know what you might be thinking is, well, if I'm doing this work on the computer, I can't physically rotate a sheet of paper this way. So another method, if you have a stationary sheet of paper or if you're looking at a computer screen, is to use what I call the anchor method. So the anchor method is the same concept of physically rotating the coordinate plane, but instead of physically rotating it, you're just going to anchor each point to an axis. So let's start with point A and rotate point A 90 degrees clockwise, starting by anchoring it from the axis. Okay, so I'm going to anchor it to the y-axis here. So I started by just drawing a line up and to the right to get to point A. So now if I were to rotate this y-axis 90 degrees, I'd be on the x-axis. And if I rotate this 90 degrees, it would become vertical. So instead of going up 4 and right 2, if I were to rotate that 90 degrees, I'd be going right 4, and down 2. And this would become my point A. Now we'll look at point B and rotate it 90 degrees counterclockwise, just to give you a different point to look at. Okay, so if I have point B, right, I'm going to start here on the y-axis. I have to go up 1 and right 3. Right, well from here, instead of going up, if I were to go 90 degrees counterclockwise, instead of being on the y-axis, I'd be on the x-axis. And instead of being horizontal, I'd be going vertical. So now that would take me, instead of going up and to the right, I would be going to the left 90 degrees and up 3. Okay, so that was our 90 degree counterclockwise rotation of point B. Right, and then let's look at point C, and we'll rotate point C 180 degrees. Right, so if I start by anchoring it to the y-axis, I'd go up to right 1. Now, if I were to go 90 degrees in either direction, that would put me on the x-axis, either way that I go. So if I were to go 90 degrees, that would put me here. I'd go right 2, down 1. And then if I went 90 degrees again to get to 180, that means I'd be going down 2 and left 1. So that was a 180 degree rotation of point C. Okay, something else that you can keep in mind is that wherever your figure is located, think about if you're rotating it however many degrees, think about which quadrant it should end up in. So if I have point B over here, this is in quadrant 1, this is quadrant 2, 3, and 4. So if I have point B in quadrant 1 and I want to rotate it 90 degrees counterclockwise or 90 degrees to the left, then that means if I start here and I rotate 90 degrees, it should end up in this quadrant. The same goes for if you were going from point A to 90 degree rotation clockwise. Again, A is in the first quadrant now. When I rotate it 90 degrees, it should end up in this quadrant. When you're rotating 180 degrees, they will always be in vertical quadrants from one another. So for example, if our figure started out over here and I rotate C 180 degrees, it should end up in the diagonal